Good morning and welcome back to math class. I hope you had a great Christmas break and that you spent some time with at least some people who were in your house and got to maybe visit people virtually or whatever the heck we all did for our Christmas break. I just hope that you had a good break and you took care of yourselves. Hopefully this will be the last week of online learning. Fingers crossed. Time will tell. Let's get started with trig, our final unit. Before we really get started, there's a couple things that we need to go through that you need to remember. The first thing is your calculator has to be in the proper mode. So when you turn your calculator on, click mode. And then when you look at your menu on mode, that's an arrow. Holy man, I make arrows like I spell not well. So you hit mode. The third thing down, you'll see the word radian and degree. Make sure that the word degree is the one that's highlighted. It probably isn't. Your default setting on your calculator is to be in radian mode, so you'll have to go down and hit enter on degree so the black box is around degree. Cool. Two more things that I want to talk about to start off our trig review. This is going to be all Math 10C stuff. We're going to talk about rounding. So when you're rounding answers, you always round side lengths to 1 decimal or your 10th. And you round angles to the whole number. So for instance, if I had a side length that was like 10.36, that would round to 10.4. If I had an angle that was 10.36, that would round to 10 degrees. Okay, so angles we round to the nearest whole angle, side lengths we round to the nearest tenth, unless told otherwise. Sometimes questions tell you to do something different. Okay, that's just some basics. So you need to be in degree mode, and let's make sure we round properly. First things first, let's do some Pythagorean Theorem. So if you have a triangle where you know two sides and you want to find the third side, your choice is to do Pythagorean Theorem. When you have Pythagorean Theorem, you have a hypotenuse. Your hypotenuse is always your longest side. So this would be my hypotenuse. I know it's my longest side because it's across from 90 degrees. And then I have two other sides. Those two sides are called your legs. They're called A and B. It doesn't matter which one you call A or which one you call B. They're your legs. Legs. Your hypotenuse does have a name. We name it C for Pythagorean Theorem. Pythagorean Theorem is A squared plus B squared will give you C squared. So in this case, it's 3 squared plus 7 squared equals C squared. We've done so much of this. 3 squared plus 7 squared in your calculator should give you 58 equals C squared. And your last step should be to square root both sides. The square root of 58 is 7.6. Awesome. That would be our answer to the nearest tenth. For our other one, if you look, this time we have A, we don't have B, and we want to find C. So there's two ways to do this. One way is to take this formula, which is our basic formula, and rearrange it. You rearrange it by subtracting B squared to the other side, subtracting C squared to the other side, to give you A squared minus C squared equals B squared. Sometimes people just have that formula and they remember it. I like to rearrange, but if you just remember that formula, hold up. It's been a long Christmas break. That's brutal. That is absolutely brutal. I would subtract my B squared. I wouldn't. I'd subtract my A squared to get B squared by itself. And B squared equals C squared minus A squared. There we go. Some people have that formula memorized. So C squared minus one of the legs squared equals the third leg squared. I don't know. I just really like to rearrange it. To do this, so that would be X squared equals 15 squared minus 3 squared. If you put that in your calculator, 15 squared should give you 225, minus 3 squared, which is minus 9. You get x squared equals 216. Your last step in Pythagorean theorem is always to square root. So if you square root 216, you get x equals 14.7. Like that. Cool. That is some basic Pythagorean theorem. And I butchered it, so that's a wonderful way to start back from holidays. Hey, Mr. Kennedy is doing math videos and doesn't know how to do math. Second thing we did in Math 10C when it came to trig is we used something called Sohcahtoa. So Sohcahtoa helped us find missing side lengths in triangles when you only had one side given to you. So for instance, if you look at this triangle right here, you notice that we know one side, but we don't know two other sides. When that happens, you can't use Pythagorean theorem. So it means you have to use something called Sohcahtoa. To do Sohcahtoa properly, you need to label your triangle using the words, I need to make a little space here, opposite, adjacent, and one of the words we already know, hypotenuse. I like to just use the letters O, A, and H, or even the first three letters, OPP, ADJ, HYP. Okay. Labeling the triangle. The hypotenuse you guys are good at. You should understand where the hypotenuse is at this point in the game. The hypotenuse is across from the 90 degree, so this is my hypotenuse. Perfect. The other two sides we used to call A and B when using Pythagorean theorem. When using Sohcahtoa, you have to name them opposite and adjacent. And it's all based on whatever angle they've given you to work with. So for instance, I notice they've given me this angle of 45 degrees. I have to label this triangle based on that angle I was given. Whatever is across from the angle I'm working with, I label my opposite. The third side is called your adjacent. So when I'm labeling triangles, I always label my hypotenuse first, my opposite second, and my adjacent is the last one. Perfect. Labeling is your first step. The second step is to use Sohcahtoa, because Sohcahtoa is actually, I'm going to write it up here. Sohcahtoa is actually a way to remember your formulas for trigonometry. So we're going to look at SO first. SOH. That tells you that sine of an angle will equal your opposite side divided by your hypotenuse side. The S stands for sine, O stands for opposite, divided by H, which is your hypotenuse. Ka tells you that cos of an angle equals your adjacent side divided by your hypotenuse side. C is for cos, A is for adjacent, H is for hypotenuse. And the last one, toa, that's tan of an angle equals opposite over adjacent. Perfect. So once you've labeled your triangle in question, your job is to pick one of those formulas, whether it be sine, cos, or tan. The best way to do that is to write out Sohcahtoa and use Sohcahtoa as a checklist. So what we're going to do is we're going to put a check mark underneath S, C, and T. Those are like your free spaces. You'll always put a little mark under S, C, T. Then you're going to put a check mark underneath the side that you know already. I know my adjacent side is 12, so I'm going to put a check under A for adjacent. Then I'm going to put a check mark underneath the side length I want to know. I want to know my opposite because it's the one that they've labeled X. So I put a check under O for opposite. Once you've put checks under what you know and what you want to know, you'll notice that one of your sections of Sohcahtoa has 3 check marks. That tells you you should use the TOA formula, which is tan of an angle equals opposite over adjacent. So it tells you what formula to use. Then, once you've chosen your formula, you need to just put things into your formula. So tan. Now, instead of saying theta, which is that angle, you would put 45 degrees. Equals, instead of opposite, I'm going to put x, because that's what the opposite is in this question, divided by adjacent. Instead of adjacent, I'm going to put 12, because that's what the adjacent is in this question. And you end up with tan 45 equals x divided by 12. You'll notice that the only thing you don't know in your formula is x, so you need to get x by itself. You do that by multiplying 12 to the other side of your equation, like that. You now have 12 times tan of 45 equals x. You put this into your calculator. 12 times tan 45 equals 12. So the adjacent or the opposite side equals 12. You don't have to put the degree symbol in your calculator, just for the record. Sometimes people are like, hey, how do you put the degree symbol? You don't put that. You just put 45. Cool. Number 2. First thing you always do is label your triangle. So this is my hypotenuse side because it's across from my 90. I'm working with my angle of 70. So across from 70 would be my opposite side. And the third side is adjacent. I'm going to write out Sohcahtoa so I can pick the right formula for this question. I put a check mark under S, C, and T because those are my free spaces. Then I put a check mark under the side length I know, which would be H because I know my hypotenuse is 8.2. And I put a check mark under A for adjacent because I want to know my adjacent. Ka has 3 checks. That means I need to use my cosine formula. So cosine equals adjacent divided by hypotenuse. We plug in our numbers, so this becomes cosine of 70 degrees equals adjacent side, which is x, divided by hypotenuse side, which is 8.2. Our goal is to get x by itself, so we need to multiply this 8.2 to the other side. If I put into my calculator, 8.2 times cos of 70 degrees equals x. I end up getting 8.2 times cos of 70, 2.8 equals x. Awesome. Hopefully this is starting to ring a little bit of a bell. We look at this question over here. First thing we do is we label our triangle. X is my hypotenuse. Across from the angle I'm working with is my opposite. And my third side is my adjacent. I write out Sohcahtoa. I then put check marks underneath the side I know. I know my H and I want to know, I know my O and I want to know my H. So I put check marks under O and H. That means sine is the one that I want to use. My formula for sine is O divided by H, which would be opposite divided by hypotenuse. We start plugging in formulas, so we have sine of 27 degrees equals O, which was 7, divided by hypotenuse, which was x. And we run into a bit of a problem. Okay, the problem here is that in the first 2 questions, when I was on this step, you'll notice that the letter x was on top. So you'll notice in these previous 2 questions, this one and this one, x was on the top of our fraction. Now, x is on the bottom. So to get x by itself, I first have to get it off the bottom of the fraction. To do that, I have to multiply x to the other side. This gets the x off the bottom of the fraction, and I now have x times sine of 27 equals 7. And now I need to get this sine to the other side, so I divide sine 27 to the other side. This gives me x equals 7 divided by sine 27. Like that. You can put that in your calculator. When you go 7 divided by sine of 27, you get 15.4. If you haven't been getting the same answers as me and you're doing the same calculations, check and make sure your calculator is in the right mode. So it has to be in degree mode. Remember, click mode, go to degree. And if that's still not working, pop into the classroom with me right now and ask me for help, and we can work through your calculator. Cool. That is Sohcahtoa to find a missing side length. Next, we're going to find missing angles. To find missing angles, we're going to use Sohcahtoa the exact same way. So the first thing we're going to do is label our triangles. This time, instead of labeling a triangle based on what angle you know, you're labeling it based on the angle you want to know. So this is the angle they've labeled as missing. So I need to label this triangle. This will be my hypotenuse. Across from my missing angle is my opposite. And then this is my third side, it's my adjacent. I then write out Sohcahtoa. I put a check mark under SCT, and I put a check mark under the side lengths I know. I know my O, I also know my A. And you'll notice one of these has 3 checks. In this case, it's TOA. That means we're using our tangent formula. So tangent of an angle equals opposite over adjacent. I then plug in everything I know. So I go tan. I don't know an angle, so I leave it as that missing letter. I then go opposite is 13, divided by adjacent, which is 12. Awesome. When looking for an angle on your calculator, you need to hit your second button first. This is for when looking for an angle. In this case, we're going to hit second, and then we're going to hit tan. And when we do that, on my calculator, you'll get tan -1 with a bracket, like that. So you hit second tan, and that shows up. What that allows you to do is it allows you to take your fraction and your angle, and it allows it to switch its spots so that your angle will now be by itself. So that means I go tan -1, I now go 13 divided by 12, and then I close that bracket, and that will tell me what my angle equals. So when you're looking for angles, you hit second and then whatever ratio you're using, sine, cos, or tan. In this case, it's second tan, 13 divided by 12. That tells me that my angle for theta equals 47 degrees. Again, remember we round degree angles to the nearest whole degree. Cool. Let's do this one. So, first things first, we label our triangle. This is hypotenuse. Across from the angle I know is my opposite. Third one is adjacent. I do my checklist. Sohcahtoa. I put checks under S, C, T. I also put checks under O and H because those are the 2 sides I know. That tells me to use sine. The formula for sine is sine of theta equals opposite over hypotenuse. That means sine of theta equals 6.5 divided by 8.2. I go second sign in my calculator so that -1 comes up. And that allows me to now put the fraction inside the bracket. So 6.5 divided by 8.2. And that will tell me what my theta equals. So I go second sine 6.5 divided by 8.2. And I get 52 degrees as my answer. Last one. We're going to go a little quick. We label our triangle. This is opposite. This is adjacent. This is hypotenuse. We're going to do Sohcahtoa. If you put check marks, you should have check marks under A and H. That means we're doing Ka. So cos of an angle equals your adjacent divided by your hypotenuse. Plug in your numbers. Because you're looking for an angle this time, you're going to hit second cos. That puts the fraction underneath the brackets or inside the brackets. You put that in your calculator, second cos 99 divided by 101, and you get 11 degrees equals your missing angle. Well, in this case, the angle was actually called alpha. It was this guy instead of this guy. So we technically should write it proper. 11 degrees equals, I think that's alpha. I think the other one we've been solving for is theta. I don't know my Greek letters. I don't teach Greek class. Cool. That is some basic trig, Sohcahtoa, Pythagorean Theorem, all the good stuff in life. So if you go here, there's 3 beautiful little practice problems for you to try out. So I want you to pause the video, give all 3 a shot. You need to find the missing side or missing angle, depending on whatever they've listed as missing. And then unpause the video, see if you did it right. Have at it. Okay, hopefully you gave it a shot. If you did this first one, you should have had it labeled like that. You should have ended up using your sine formula. So you should add sine of 27 equals opposite, which is 7, divided by hypotenuse, which is x. You should have multiplied x to the other side and then divided sine. So you had x equals 7 divided by sine of 27. Throw that in your calculator. 7 divided by sine 27 gives you 15.4. Beautiful. For B, you should have labeled your triangle like this. H, O, and A. When you did that, you have O and A, so you should have been using tangent. So tangent of your missing angle would have equaled O, which is 6, divided by A, which is 11. Since you're looking for an angle in this question, we would do second tan, 6 divided by 11. And that would tell you your missing angle. Second tan, 6 divided by 11. It's 29 degrees. It was 28.6. That rounds to 29 degrees. And the last one. If you labeled your triangle, this is hypotenuse, this is opposite, this is adjacent. So they've turned the triangle a little bit, right? But opposite is always across from the angle you're looking for. Hypotenuse is always across from the 90. If you did this, you should have used your sine ratio. So sine of a missing angle equals opposite, which is 21, divided by hypotenuse, which is 25. Since I'm looking for an angle, I did second sine to get that -1 up there. So I got 21 divided by 25. Second sine, 21 divided by 25 is 57 degrees. And that's my answer. Wicked. If you can do that stuff, you're pretty much set. Okay, so on your practice booklet, make sure you can do all those Sohcahtoa problems. Just work through them, crush them, do good on them. If you scroll down to here, we have a couple more harder problems. I'll do the first 2 with you. You can feel free to do the second 2 if you want. But the first 2 are the only 2 that really matter today. So First one says a point is located at 3, 5 on a Cartesian plane. All right, a Cartesian plane. The heck is that? A Cartesian plane is like a graph, like an XY graph. So when they said a Cartesian plane, they're meaning on a graph like this. They said a point is located at 3, 5. So if you went 1, 2, 3 over and 1, 2, 3, 4, 5 up, you would have a point. Perfect. Determine the distance from the origin to this point. Origin means the very center. So determine the distance from the origin here to this point. So determine this distance. I missed. Let's try again. Determine that distance. Cool. If you're looking at that, you might be like, I have no idea what that distance is. The way that you're going to figure this out is by realizing that there's a triangle here. If I was to build a leg over and a leg down, I've now turned this into a right angle triangle where the 90 degree is right there. And these side lengths they gave me, 3 and 5, actually tell me the side lengths that I just drew in yellow. So this must be a length of 3, and this must be a length of 5, because it was 3 ticks to the right and then 5 ticks up to find that point. Now I have a right angle triangle that looks like this. 3, 5, x. This is a Pythagorean Theorem question. This is a squared plus b squared equals c squared, where c is your hypotenuse and b are the other two. So this is 3 squared plus 5 squared equals c squared. 9 plus 25 will give me 34 equals c squared. Your last step is always to square root both sides. The square root of 34 is 5.8. So my missing side, or the distance from my origin to that point, is 5.8. Cool. The setup's the hard part on that one. I think the important thing, especially moving forward with what we're going to do in math, is realizing that a point on a Cartesian plane creates a triangle. So whenever they give you a point on a graph, you actually do have a right angle triangle. Cool. This second question is what I call a double triangle question. So if you look, you can see that there's actually two 90-degree triangles here. There's one right here. We go up, down, and to the right. You'll see we have a 90-degree triangle. There's a second 90-degree triangle right here. Down and over and down. There's another 90 degree. Perfect. There is a third triangle here. The third triangle looks like this. Whoa, that's not a triangle. That's a square, Mr. Kennedy. Your third triangle looks like this. That big green one. All right. The big green triangle means nothing to us at this point in our lives. The reason why is because our trigonometry that we know only works with 90 degrees. And that green triangle is not a 90-degree triangle. It might look like it, but it's not. Right? If they don't tell you something's 90, then it's not 90. So for this question, that green triangle is irrelevant. The only triangles that matter are the red one and the blue one. Perfect. The question says, solve for x to the nearest tenth of a centimeter. X is a part of our blue triangle over here. If you look, when I look at x, I only know one thing about x. I only know this angle of 60 degrees. I know nothing else. To be able to find things on a triangle, you always need two pieces of information. Whether it's two sides or an angle and a side, you always need one of those two situations. This situation, I don't have that. So that means I need to get more information. I need to find one of these side lengths to be able to even do anything with the blue triangle. When I look at the red triangle, I do have enough information. You'll notice I have an angle given to me and I have a side length. That means I could find the other sides and the other angles if I wanted to. Now, if I use a little bit of logic here, if I found this side length, then I would now know this question mark and I'd be able to find x. So this question, you have to do two steps. You need to use the red triangle to find the shared side between the two triangles and then solve for what the question wants. Whenever you see these double triangle questions, typically always the question hinders on finding the shared side. Sometimes it's a shared angle, so I'm going to say find shared info, but in this case I'm just going to say shared side. Your shared side is this side length right here. See how both triangles use that side. Using my red triangle, I would have to label this using Sohcahtoa. So this is my hypotenuse, this is my opposite, this is my adjacent. If I do Sohcahtoa, I would end up using tangent of 33 degrees equals opposite, which is y, divided by adjacent, which is 12. That means if I do 12 times tan of 33, that will tell me what my angle, my side length y is. So 12 times tan of 33 gives me 7.79289 1118. Notice that I'm not rounding my number. I'm not rounding my number because it's not my final answer. Cool. Now, looking at my blue triangle, I know this side length. Therefore, I can do Sohcahtoa on the blue triangle, where this is my opposite, and this is my adjacent, and this is my hypotenuse. Using Sohcahtoa, I'm going to end up using Toa again, but for the blue triangle, so it's 60 degrees, equals opposite, which we just solved, 7.792891118. 1118. I missed a 1 in there. Divided by my adjacent side, which is x. To solve when x is on the bottom, I'm going to have to multiply x over here and then divide by tan to both sides so that I get x equals 7.792891118 divided by tan of 60. You put that in your calculator, and this time we are going to round because it's our final answer, and I get 4.5. So the distance, x, would be 4.5. Cool. There are some practice questions in your book on stuff like that, so feel free to try them. There's 2 more here that you can go ahead and try as well if you would like. I'll write down the answers. I won't go through them because I think this video is long enough. So if you were to do this first one, you should have ended up with a triangle that looked like this, where the H.J. Cody would be this tall side. The distance from Francois to the school is 10. The angle of elevation goes there because you're looking up. An angle of elevation means going up. If you do some Sohcahtoa on that triangle, you should get that the distance x equals 11.5 0.50. And then to actually get the proper answer, because that isn't the height of H.J. Cody, you'd have to add the height of Francois, which is 1.78 meters. And that would give you your total answer, which is 13.28. You'll have to do the math on that to figure that out. The 1.78 is the height of Francois because technically this is the top of Francois's head, so you'd have to add this missing gap of 1.78. Tricky. If you look at this one, what you would have had to do is you would have had to find this distance ln from here to here. The only way you're going to do that is if you take this long distance from L all the way to O, and then subtract this distance n to O. So if you do your trig on that, from L to O should have been 13.109. The blue side, which would be N to O, should get you 5.604 ... And that means the distance from L to N would be LO minus NO. So if you took 13.1 and subtracted 5.6, you end up getting 7.5. And make sure you don't round, right? Like use all those decimals until your final answer. You can do the Sohcahtoa to see if you're doing it right. Those are the final answers. Take care of yourselves. I will chat with you later. Make sure you're popping in the classroom and asking me any questions. This basic trig, you essentially have to be perfect at it. So you better practice and make sure you're good at it, and make sure you ask for help if you don't remember it. Awesome. Take care.